Hello, I am Jamie Wood with Senior Design Group 11. This is our defect prediction data mining project. We're going to split this project into two main parts. I'm going to talk about the underlying data miner, and then here in a while, Andre is going to talk to you about the graphic user interface that has been wrapped around it. Data mining is essentially the process of extracting patterns from sets of data, typically too large or complex for a person to understand on their own. These patterns are normally referred to as rules. And in the case of our project, the rules we are trying to generate are ones which better predict for the defectiveness of software projects. Initially, we were researching effort estimation data using a learner called W2. After working on this for a while, we wanted to try and use the same machine learning techniques that are used on effort estimation on defect prediction data, which had never been done before. Unfortunately, W2 was written in awk, which neither of us had very much experience in working with. So we took a learner that is very similar called Which2, which we already had a base of code in Lisp that we could work with. The way Which2 works is it generates a contrast set of interesting attribute value pairs and then proceeds to take these and combine them into compound rules until it doesn't see any improvement and returns the best set of rules it can generate. Once we got this running over defect data, we realized there was a significant problem. That is, there is a far greater number of flawless instances of data than there are defective data. It makes it very hard to learn using contrast sets when there is nothing to contrast. The first way we try to combat this is we grouped all of the defective data together. That is, anything with any bugs was labeled defective, and anything without bugs was labeled flawless to make the target class a little less rare. We also changed the way we were discretizing and logged the data before learning on it to even the bins up better. Once we did that, we had significantly better results. To try and see how effective this type of learning was, we went to Promise repository of datasets and took all of the multi-version defective data. The way we ran over this is we would train on one set and then test on another, and then train on those two combined and test on a third, and so on and so forth. The benefit of doing this is that we were able to gauge not only inter-project stability, but intra-project stability as we were running over the same project multiple times using different versions. The entire time we were doing this, we were doing it through the command line, and in order to make it a little bit more usable for anybody other than ourselves, we figured that we would have to add a graphic user interface. And to talk to you about this is Andre Perhinsky.
Hi everybody, my name is Andre Perhinsky, and I'm going to talk briefly about the graphical interface part of Group 11's project. First off, I would like to mention several design decisions we made early on during the project. First of all, our graphical interface's name would follow its function, and as such we named it simply Which2Gui. We decided it would be written in Python using the GTK Plus Graphical Toolkit API that is available on a great deal of different operating systems and environments. Despite the portability of its software dependencies, Which2Gui was written and tested entirely on an Ubuntu Linux 10.10 machine, and it has never been tried on any other operating system. However, that being said, all POSIX compliant operating systems should be able to run it given the proper dependencies are installed. From the beginning, Which2Gui was designed to be as flexible as possible in terms of what it expects when loading data. The only data file format it accepts is our own .lisp file format. However, despite only being able to read this one format, there are many types of data that can be included in it. There's no maximum number of attributes each historical instance is allowed to have, or a maximum number of dependent classes. Because of the flexibility of this file format, Which2Gui has the capacity to figure out how many attributes we have, what all of their labels are, as well as which ones represent the dependent class that we are trying to find rules for. All of this is done each time a new dataset is selected. Since half of the system is written in Lisp and the other half of it is written in Python, we realized early on we would need to somehow interface the Which2 Lisp code with our graphical Python wrapper. And the decision we made regarding this issue was to avoid using inter-process communication methods such as shared memory or pipes in favor of much simpler file-based message passing. We simply did this because we figured it would be much easier to implement and introduce the least amount of potential for things to go wrong. At first, we assumed we would have to use several different files to enable our system to share all of the information required amongst itself. However, as we progressed with coding both parts of it, we realized we could make all the data that we needed shared available in a single file. This file, we named it main.lisp and placed it in the which2 root directory, where it still resides. Main.lisp also has the function of storing configuration settings besides being the only communication present between our Lisp and Python environments. As such, we consider it a very important linchpin within our system, and we provide exception handling for situations where this file may be corrupted, non-existent, or in some other way unreadable due to permissions errors or something like that. In such a case, Which2Gui loads a sane set of hard-coded default setting values and rewrites main.lisp to avoid future issues. Now, getting to the functionality of our software, Which2Gui enables a user to perform two different data mining operations. First, we have a train test run. This is where Which2 trains on one set and tests the resulting recommendations or rules on another set. The second operation Which2Gui can perform is a custom rule test, where a user-created rule is tested against one single data set. Next, I'm going to demonstrate this functionality, starting with a train and test run. Now, in order to perform a train and test run, we need to select a data set for each stage of the process, meaning a data set for training and a data set for testing. The interface will not allow the user to train and test on the same data set, as we believe that would not make any sense. It would not produce any meaningful results. As we can see here, the interface automatically unclicks the test or train selection if the other respective column is selected. At the same time, the interface will not allow a run to be started without having selected both data sets. If we try to start one right now, it'll tell us that we need to select the set to train on. Of course, we select the same set to train on, it'll tell us we need a set to test on. Having selected both sets, really all that is left to do is to click the train test button and wait for the run to complete. Now, while this is going on, the Lisp code is running in the background. The interface displays a status message of working in the bottom status bar, right down here. Also, the progress bar, located at the far right of the status bar, flashes while Which2 is running. When the Lisp code is finished, the results are added to the top of the results list, and the status is set to idle. The second data mining operation that I want to go over, that Which2Gui provides to its users, is custom rule testing. Now, custom rule testing, for this we only need to select one data set, and the data set that we want to test against must be selected under the train column. The test column could also have a selection. However, this is not required. The custom rule testing only uses one single data set, and if a test set is selected, it will just simply be ignored. No exceptions will be raised or error dialogues or anything like that. It will just be ignored. Now, rules are simply tuples of attributes and values. They consist of the attribute name and a bin value. These bin values, the bin values available depend on the bin number set in the configuration dialog that we will go over in just a minute. We can also add any number of attributes we wish to a rule. There's no limit to the number of attributes we can add. We can also remove them if we've decided that we do not want a particular one. The operation begins as soon as we click test rule. Everything will proceed in the same manner as before. The progress bar will flash from left to right. The current status will display working, and the results will be shown at the top of the results list. And that was a very quick run. Now, the configuration dialog. The configuration dialog is accessed through the configuration button up here. It offers several Which2 configuration options. Some of these setting values are provided through drop-down menus, such as goal, discretization, and the scoring metric. Others, as we can see, are simple text entry boxes. Now the values for these settings are all stored inside main.lisp and reloaded whenever Which2Gui starts up. Default values can be loaded by clicking the revert button. Well, they have to not be default in the first place. As we can see, they are now changed. When I hit revert, the dialog window will go away, and supposedly the configuration settings are now set to default. As we can see, they are the same as the first time we pulled up the dialog. Now, the default values are also loaded in the event of a non-existent corrupted or otherwise unreadable main.lisp file. All of the configuration options seen here are described in our design documentation. Now, having seen the rule dialog and the configuration dialog, we have two dialog windows left that are available for us in Which2Gui. These are the usage and about dialog windows. Now, the usage dialog simply displays the user manual for Which2Gui. This is the user manual as is found in our final design documentation. The About dialog window just displays the program version. It contains a link to the project website and also contains credits and contact information for us. The last dialog that the user actually sees before exiting Which2Gui is the confirmation to quit. With this, we conclude our short video on our senior design data mining project. We both want to thank you very much for watching this. This has been Andre Perhinsky and Jamie Wood, Group 11 signing off.